Hi, thanks. Those were amazing words, and I'm delighted to be here. Good morning, everyone. How's everyone doing? Sweet. So my name is Josh. I work for DigitalOcean. I live in Montreal, Canada, and so to get here, hey, represent. I had to fly to get here, as I'm sure many of us did. I'm actually curious if you can raise your hand if you flew to get to this conference. Wow, that's like 2/3, 3/4? Do me a favor, keep your hand raised if you enjoyed your flight. That's like 7 or 8 people. Okay, so that's kind of a shame, I think, because flying is this remarkable thing. I was fortunate enough a few months ago that I was flying back. I had a window seat over the wing during a sunset over the clouds. And it was amazing because you have this like vast, rich landscape that humans were never really like, who could have imagined this was a thing that we'd be doing like before we had planes? So it's this really cool thing that is almost never enjoyable because of all the like tedious and troubling parts around it. And because of that, it's a shame. And I think that like the part of this that we hear discussed very often online, one of the more contentious areas is around boarding, actually getting on the plane. There is no shortage. In fact, there is a surplus of articles complaining about plane boarding. Even Mythbusters did a segment where they built a fake plane, got 150 volunteers, tested different boarding strategies. They even dressed up as a like look at, he has a pilot outfit. And in the end, they discovered that there was a better way to board a plane. We're doing it wrong. So, I think that boarding is really important because it sets the tone for the flight, and the quicker you get people on the plane, the less time you have to spend on the plane, so that's good. But I don't know that it's really the biggest problem with air travel. I don't know if I'm speaking closely enough to this. Yeah. Okay, this has been like a windy road, and I appreciate everyone coming down it with me. But the reason I'm talking about this is that I think it has interesting parallels with performance. So when we talk about performance, typically, we're thinking about like rendering on the server, or like with Gatsby rendering at compile time, to deliver like a fully formed HTML document. We do code splitting and tree shaking so that we can deliver smaller bundles so that the page is interactive more quickly. We optimize our assets. We lazy load things. We do all this stuff to make it so that the page loads and is interactive as quickly as possible. We don't tend to focus as much on everything after the page is ready. And this is kind of a shame because usually we spend more time using products than waiting for them to load. So this talk is called Saving the Web, 16 milliseconds at a time. The talk is like a little facetious. I mean, it's a little over-exaggerated. But I do think that animation performance is more important than people realize. So I think it's valuable to think about how we got here and why we prioritize things the way we do. And we can go back all the way to 2012 when articles like this started popping up. How 1 second could cost Amazon 1.6 billion in sales. It had this cute little infographic that shows how like the more time you wait, like there's that grumpy guy who's bailing while the other 3 people are still happy. There's like modern articles about this too, like this one's from this year. It's not clear to me why this article chose this photo of a guy mansplaining something to a clearly unimpressed coworker. But that's their choice. And it's true when you search for air conditioners, right? We're in Salt Lake City, it's hot. You're presented with so many choices. And so if I click that first link and I get a blank screen and 2 or 3 seconds pass, I know that I have this whole list of other places that also have air conditioners, and it's trivial to use the back button to go back and then try the next one. So when you're in this kind of environment, the e-commerce SEO game, it really makes sense that load time is important. And it's important in all situations, but especially this one. And I think the fundamental fact here is that humans aren't patient. I'm not patient. Like, I'm totally, like this guy, the grumpy guy with the beard, that's totally me. I'm the one bailing after 3 or 4 seconds. And I think that it's true that we remain impatient after the page is loaded. We don't suddenly become much more gracious when it comes to things being slow. So I have some numbers. Interaction is like if I click on something or if I type something, how long am I willing to wait until I want to see that change reflected in the UI? How much duration is there before the feedback? And the general guidelines are like 50 milliseconds, 100 milliseconds. Animation, it's even trickier. You only have 16 milliseconds because to convince your brain that this is something moving and not just something being drawn in different places, you want to run it around 60 frames a second, which when you do the math gives you about 16.5 milliseconds. So let's talk about interactions. So here's something I saw recently this week. It's really, really cool. I'm going to click on it. It's by Monica D. I'm not going to try and pronounce her last name, but she does amazing work. And the idea is that it's a text box you can type in. Hello there. And you can tweak the delay. So at 5 milliseconds, it's not noticeable, it's fine. If you set it to 100 though, then all of a sudden, it's really kind of bad. If I set that to 200, it's like, oh boy, this is not a great, I can't even actually type. That's not helping. And it shows that it's like really frustrating when you want to see the feedback and you're not getting it. So really helpful tool to like, and we all kind of can empathize with this because we've all been in situations where things have behaved this way and it's frustrating. So another thing I saw this week that was really, really interesting was there was this blog post on the Orange website by, I guess his name is Hello Wayne. It's about, so he was recently certified as an EMT, so the people that ride in the ambulance. And when you pick someone up that's having an emergency and you take them to the hospital, while you're in the ambulance, you're supposed to fill out these PCRs, patient care reports. And the idea is that this is a document that will help the handoff. So that when you get to the hospital, the doctor can get like full context as to what's happening, what the condition is, what the circumstances were. And it's tedious to fill in by hand. 30 million of these get filled out every year, and I think that's just in the US. And they're written in these like high stress situations, like you're in an ambulance and there's like a life on the line sometimes. And the thing is that mistakes are really serious. Like an example from the article is if someone writes 160 but the doctor reads it as 100, that's like a problem, right? So they built software for this. They decided that they could build something that would make it to solve this problem. And they trained the staff, they invested a ton of resources into it, they fixed the bugs, they got it working, and nobody uses it. Everyone still uses the paper, even though it takes longer to use the paper. The reason for this is that the machine that runs the software is very, very slow, and you wind up with a 250 millisecond delay. So like, going back to this thing, like 250 is a wild delay. There it is. So like, it's understandable that people would go back to paper, even though in this case it has serious consequences for accuracy and reliability and even speed. So I think that this goes to show that like, while most of us aren't working on stuff that is this like, life or death, it proves the fact that people really don't like dealing with this kind of input latency. And the thing is that it's kind of hard to measure this. Like we have pretty good tooling to measure how long a page takes to load. We don't really tend to measure how long it takes to respond to an input event. So there are tools that we can use to solve this kind of problem. I'm not going to go into them in depth because there's actually a surprising number of resources for this. Oh, my window is all sideways. Fix that. So like the traditional one was should component update. More modern is React Memo. The idea is that if we can control rendering, if we can make it so that we're not rendering wastefully, we can reduce a lot of the time to process these updates. There's a really good blog post from Scotch.io, and the official docs are pretty great too. And I think that it's easy when discovering these tools to go a little overboard with them and to start optimizing everything. Ultimately, it's really important to like profile this stuff and see where the problems are. Because it is really worthwhile to fix these problems, but you don't have to do it all over the place. There's also, we heard a bit about this earlier today, really exciting work coming with scheduling. And so React has a concurrent mode in an unstable version right now where you can set priorities for updates. So if you have this really high priority thing, React makes this API available that makes it really nice. And Philip Spies has a great blog post about it, although it's still very much, they're working with the Chrome team on it, and that's awesome. But it may not make sense to use this in production yet. So what about animations? I feel like input response can be animation related, but it's also not exactly the same thing. So I don't have like a compelling anecdote about ambulances when it comes to animation, but I still think it's really important. And I think it's because while animations do a lot of things, one of the things they're really useful for is making the product feel real and tangible. And I think Apple products do a really good job of this, that when you use even an iOS calendar app, it's like you're interacting with it, you're swiping things, you're moving around. It feels like you're doing a real thing, which you don't get when you just use like a static document. And I think because we have, the web is no longer an isolated ecosystem. Everyone uses web apps and mobile apps every day, and they can contrast the two. So standards have gone way up. I have a question, and I'm encouraging people to shout out answers. How big do you think the native Facebook mobile app is? Okay. It's not quite a million. 255 megabytes. And the thing is, this is a dramatic improvement because a few months ago it was 460. So like, it's a significant amount of stuff to download. And when you think, like for comparison, Mario 64, 32 megabytes. And that was a really big game. Like, they had a lot of worlds and stuff. And when we think about how much friction it takes to install an app, like first you have to find the app in the App Store. It's going to prompt you for your password. You're not going to remember what your password is. Download hundreds of megabytes, possibly on a mobile connection where you have limited bandwidth, onto a phone where you have limited storage. Wait for it to install. Figure out which home screen it's on. Like, I never can find it. You have to swipe for the icons. Tap on it, wait for it to open. It's like dramatically different from just going to a URL. So the question is, why does anyone put up with this? Like, why not just use the web for everything? And there's a lot of reasons, but I think one of them is that mobile apps, after all that, offer a much better user experience. There was a really interesting episode of the React podcast with our very own Chantastic, where he interviewed Matt Perry. And Matt Perry had a really good point about how he sees this as a matter of relevance. He believes that animations play a pretty big role in making sure that the web remains relevant. So in much the way that AOL quickly became something that only our grandparents used and then it became not a thing at all, we can imagine a world in which mobile apps become so popular that it makes the web this what's the word I'm looking for? Artifact is the word. It becomes like this artifact that isn't really part of popular culture anymore. And this to me feels like kind of a shame because the web is pretty remarkable. For all of its problems, and there are a lot of problems, there's such amazing tooling. Like, you can go to the electronics store, buy a laptop, access something like Code Sandbox right away, and use it to build an app for the web, on the web. You can deploy it instantly. It'll be available worldwide through a CDN. All of this for free and almost immediate. And it's amazing. Knocked over a water. Yeah, it's pretty remarkable that we have this. Because I think the web is really low friction, and it's that way both for people consuming it, so our users, and for people developing for it. And because of that, we have all this amazing content that you don't really see in the mobile space. So, if we want to make sure that the web stays relevant, I think it's really important that we build experiences that can compete with what's happening in the native world, and I think animation performance is a part of that. So let's look at an animation. I'm going to pick on Bootstrap a little bit, and it's not even that Bootstrap is particularly worthy of being picked on. It's just that accordions are generally hard to do right. So this is an accordion, for those who don't know the term. It's this idea that you have multiple collapsible things. I'm going to open the DevTools and go over to performance. I'm going to throttle this because this computer is not representative of most. And then I'm going to poke at it. I'm going to open this, open that. Let's see what we get. So it doesn't perform great. If we zoom in, we'll see that we're averaging 25, 30 frames a second, which is like half of what we want. And if we dig into why, I'm just going to pick a frame here. You'll see that we're spending quite a bit of time with these purple bars in what's known as the layout step, and then a bit more time in paint. And these two steps are really, and it's 3 steps, but these two purple are both part of layout. They're really responsible for how long this takes. And the reason, part of it at least, is that if we check this paint, it's repainting the entire window on every frame. And it's because whenever I expand one of these things, everything below it shifts up and has to be repainted on every frame. And it's expensive to do so. To understand what's going on with this, we have to talk about the pixel pipeline, which is a really cool term. I gave it a cool image. I don't think the actual process has as much pizzazz as this slide makes it seem, but there we are. There's a really good blog post about this called Rendering Performance by Paul Lewis. I'm not going to be able to do it justice in the time that I have here, so I highly recommend folks read it. But just to summarize a little bit, these are the steps that can be involved when an update is pushed to the screen, when stuff is repainted. So there can be a JavaScript trigger that starts it. Style, I think, is the process of figuring out which CSS rules apply for every element. I don't actually know because it's almost never a problem. Layout is the process of figuring out where stuff has to be. So if things move, if they change size, where are all the elements? Where are there bounding boxes? Paint is the process of figuring out which color every pixel should be for every layer that you have and filling it in. And then compositing is the idea that you have all these different layers that have been painted, and you can just stack them in a way that makes sense and do some transformations on them. So what's interesting is that not all CSS properties are treated the same. So for example, background color, it's never going to trigger layout because there's no value I can set that will cause the thing that has a new background color to have a different size. It's only ever going to cause paints because it changes the color of things. There's a cool website called CSS Triggers that kind of shows which CSS properties affect which steps in this pipeline across different rendering engines. Pretty useful. the golden rule, like the standard advice, is that we only really have two properties that can be used to skip both layout and paint and thus cause really robust performant animations, and they're opacity and transform. Opacity is just how visible something is. You can make it transparent. Transform is like a bucket of different things that it can do, like it can move stuff around, scale things, rotate things. So how do we use this to create a better accordion? Well, the tricky thing is, it's not so easy, because everything on the page moves around, and so how do you avoid layout when the layout's changing like that? So here's what I came up with instead. I have this accordion that has cats. The cats, incidentally, are Scottish fold cats, which have funny ears, so that's why I picked them. And the idea is that, so the first thing is that I have this little swiveling carrot, which isn't the most consequential, but I think it's cute. The main thing, though, is that when I click to expand this, the child below immediately jumps to its new position. So you only pay the cost of that layout and paint on the first frame. And then for every other, what I have, where's my cursor? There it is. Every other, I'm doing a transformation on the children. So there's a subtle vertical motion. Everything still moves down by about 12 pixels, which gives you the sense of like vertical movement when you click to expand it, which I think is important. And it fades in. All right, so first code sample is going to be very, very rushed. Ultimately, I think this talk is more about high-level ideas, and all this code is going to be made available at the end. So I'm going to move pretty quickly through it. But I have an accordion item component that receives the title, which is the thing to display in the trigger, and then the actual collapsible content. I have a button. When I click on that button, it triggers the thing to open and close. It contains the title as well as the little swiveling carrot. And for that, it's a CSS animation, or a CSS transition, where I'm setting rotate to either be 90 degrees or 0 degrees so that it goes from pointing to the right to pointing down when it changes. And then I set a transition so that it happens over 400 milliseconds. And then for the actual children, I just wrap it in a div, and I add a class name, and I selectively render this depending on whether or not it's open. And then if we check the keyframes for this, I have a little animation that essentially moves it from -10 to 0 so that it moves down, but it starts offset. And then I have a fade in, and then I just apply it as a keyframe animation. It's worth talking briefly about the fact that this pattern makes me a little bit nervous sometimes, because we don't know how big children is, and in this paradigm, whenever this value changes, React will see that this is no longer needed and remove it from the DOM, and then when it changes, it has to insert all those nodes again. And like DOM insertion is not a cheap thing to do, but in my testing, it really didn't seem to be too big of a deal, even with quite a bit of content. So it's just important to like know that this could be an issue, but usually I think this is an okay pattern. I'm curious actually, has anyone ever heard of the will change CSS property? Okay, cool, that's maybe about 10% of the people. So the idea is that will change is a way to inform the browser that something will change. The way that it is currently used in terms of implementation, I think, is that this is how you set something to have its own layer. So like, if you want to only composite and not have to paint, it has to be its own layer, and this is a way to suggest to the browser that this thing should be. The trade-off with this, though, is that if you apply it to everything, you're going to have all these layers, and it uses up a lot of video memory. So it's one of those things where it's generally recommended only to use it in cases where you have a problem and there's no other easy fix. But it can be really, really useful as a way to get really, really performant animations if you use it very selectively. Another thing that I think is important to talk about is that we have these like golden rules that these are the properties you can set. You don't always have to follow them. So when I was at Khan Academy, we had this menu, and we did it the like standard accordion way. And what that meant is that we're repainting and calculating layout on every frame. But it actually wound out okay, and it wound up okay for two reasons. The first is that it was primarily used by teachers on desktops, and I think we even had a different menu for mobile, so we didn't have to worry about underpowered mobile devices. But the other thing was that I knew that I was never going to have that much content, so the amount of stuff being painted was pretty small. Okay, let's look at something else. So I created essentially a clone of this little tweet thing, and I added my own little heart here. This was for a workshop I did. Just to zoom in and look at it a little bit. Actually, I'm going to steal some of this water. So it's not actually exactly like Twitter's real like button. I took a couple of liberties, but it's kind of fun. So if we look at it, there's the heart that kind of does this swelling thing. There's the pink popping bubble behind it, and then there's the particles, which are just like circles that move in random directions. When we look at the performance of this animation, and I'm not going to show the code for it at all, but the code will be made available for those who are curious, it does technically work. Like here I'm throttling, and I'm still fitting in that 60 frames per second budget, but it's really tight. Like it's not a comfortable fit. And the thing is, I used a library called React Spring for this because it's wonderful and it creates really natural motion, but that means that it runs on the main thread. And Vincent Reamer built this really helpful little demo, which kind of shows the same animation done through various tools. So if I click on this checkbox, what it does is it starts stalling the JS engine. It just gives the JS thread work to do. And you'll see that like the first two animations hold up all right. They're not really affected, but the two on the end, they're stuttering a little bit. They're feeling it. And this is just a consequence of doing multiple things on the main thread. And so I have a concern here that I have this like button. When I click on the like button, I have to make a server request to actually make that change permanent. And what if like parsing that request occupies too many resources at the same time? So how do we fix this? One option could be to use less particles, but I don't want to do that. I like the particles. Another option could be to use a CSS transition instead of using React Spring, but then you sacrifice the quality of the motion. I really like the way things move. The last option is one that I don't hear too much about, which is to use sprites. So this is like a video game thing, but the idea is that you have a recording, like an animated GIF, and you split it into a bunch of still frames. It's kind of hard to see, and I don't think I can do very much about that. But essentially, it's just every frame in this animation as a still. And so you could just like show an animated GIF, but there's tools built into the browser that makes it really neat to work with. And as you see, like it looks pretty similar. It looks good. So if we look at how this works, I have a wrapper, which renders an image. I'm using style components here, but it could really just be any CSS. Like it doesn't have to be. I have a keyframe animation, and I'm going from translating it from its normal position to negative 100%. And what's interesting about transforms is that unlike almost everything else in CSS, the transforms are relative to the child. So it's not 100% of its parent, it's 100% of its own size. So it's moving from its normal spot all the way until its right edge is at the left edge of the container. So then I have a wrapper, which is the container element over here, and I'm essentially cropping a square. So the first frame, let's say my image is 72 pixels tall by 2,500 pixels wide. I'm cropping the first square and then hiding the overflow. And then my keyframe is the animation I defined, 1,000 milliseconds. This bit here is the magic part, which is steps. And it's a timing function, so it's like ease or linear or Bezier curve. But it essentially, like a staircase, makes hard jumps between n values. So I have 34 frames in this thing, so I'm saying that I want to have 34 jumps. And it just hard cuts between those positions, which means that it plays it like a flipbook. It jumps by one frame in 1/34 of the time that I have. I actually should have made this a bigger number to make it run faster, but you can tweak that. Performance of it is great. Like it has to do very little work. It's essentially playing an animated GIF. And so you could even have even more particles. Like you don't have to feel limited. To make this, I use a couple tools. I use something called Giphy Capture, which is just like a way to screen record a GIF. EasyGIF is this neat thing that takes a GIF and turns it into a sprite sheet. And then I use Photoshop just to like remove the background. OK, I have 3 minutes left, and I have one more thing to talk about. So I built a thing a while ago called Synth. And the idea is that it's a generative art experiment. And so after it loads, you have, by the way, I did a kind of a bad pattern there, but I really liked my spinner. So I forced the user to sit through the spinner for the first 2 or 3 times they see it. And then so like this is actually how much time it takes to load, but I like the spinner. Shouldn't do that though. OK, so essentially you have this art on the left, and then I have controls on the right. So as I tweak these parameters, it moves the stuff around. This one in particular I think is kind of cool. I have no idea why it does the in-between. I'm just going from Cartesian coordinates to polar, but it looks neat. So I built this project just for fun, and I had a problem. The problem was that this is how it performed. Keep your eye on the like spinner there, and like that input lag is not fun. And the problem was that I have all this stuff happening at the same time. I have the work needed to compute where the lines need to be drawn. I have the actual visualization, so the colorful lines in the little box, and then the slider itself. And they're all fighting for resources. And it takes a while to compute those lines, because the way that I did it is that let me actually go back to it and do this. Every row is a series of straight lines. So this white line is, I think, 500 straight lines. And then to deal with the occlusion, so if I turn this knob, then, and let me actually, this color isn't the most visible. Like the second line will have to check and see if it goes behind the first line, and it does that by checking every individual straight line. So it does that 500 times for every previous line in the series up to a reasonable point. So it's like a lot of calculation. And I realized that like we have this tool that has been around forever that we almost never think to use, or I never think to use, web workers. So you can run all that like work to calculate where all the points have to be in a separate thread, and that way it's not interfering with your slider. So I did that, helped a lot. Incidentally, there's this article by Surma about how we should all be using web workers more, which is like a really like sobering read, and thus highly recommended. I also took advantage of this new API called the off-screen canvas. And the idea is that it lets you paint to a canvas in a worker thread. So typically worker threads have this one big disadvantage, which is they can't access the DOM. So you can do calculations, you can't update stuff in the DOM. But off-screen canvas lets you transfer control to a worker, and then that worker can do whatever it wants with that canvas. So those two things together turned this thing from like a non-viable, horrible experience to like something I think is pretty fun to use. Sadly, it only exists in Chrome. I hope that'll change. The good news is that it's not like the worker stuff still works everywhere. And so you're still getting the bulk of the benefits. You just can't actually perform the drawing in a worker in most browsers. OK, so I don't have time to show that code, but again, it's available for those who are interested. I think that the takeaway that I'd like to talk about is that people really hate when pages take forever to load, just as they hate things that don't respond swiftly when they click on things or type things, just as they don't like animations that don't run well. Like, all of this is bad. And I think that we have a finite amount of time, right? We don't have the time to fix every performance issue. So we should figure out which is the most important. And I think if you're building something to compete with Amazon, it's true that like when you have that list of search results and you want to make sure that the person's not going to jump to the next one, you really want to make sure that you're jumping, or that you're like optimizing for that problem, because that problem seems the most evident. But it really depends for other apps. I think that the best thing we can do is we can test our product on low-powered devices, because it's hard to trust the measurements because we're not measuring everything super well all the time. And just like use your human intuition, like try using it and see what feels the worst, and then like solve that problem. All right, that's my talk. Resources available there. Thank you.